let's just kick off. And Carlos, why don't you tell us about yourself and about your work?
Yeah, thank you all so much. Happy to be here, and I'm happy to get stopped and interrupted if there are any sort of confusions or doubts. Would enjoy keeping this very conversational. So Edie has hit
I'm
the nail
thrilled
on
to be
the head.
here.
I focus on the health effects of environmental exposures, in particular air pollution and extreme temperatures, but also in particular on how we might think about reducing exposures to improve health, especially for those most vulnerable. So my research has fallen into two big buckets. One is sort of on this environmental epidemiological sorts of questions, health impacts of wildfire smoke, health impacts of temperature, and really trying to understand what we know and don't know and push the boundaries on methods. And the second big group is on clean energy interventions and transitions to cleaner energy to address both climate change and deliver health benefits.
Great. So we're gonna. This has been billed as the an event around cities and climate change. So whenever possible, let's bring in issues around cities and the future of cities. If we start first of all with some of your work around wildfire, smoke, and health. You've uncovered some unexpected trends in what happens in emergency rooms. So when wildfire smoke gets extremely bad, actually fewer people go to the ER, even though we know that smoke causes more harm the higher the levels that it gets to. Why is this?
Yeah, it may seem counterintuitive, but I'm going to share some slides and hopefully walk through the logic here. So we do definitely believe that wildfire smoke is bad for people, but people also change their behaviors. So why do we see drops in ER visits during extreme wildfire smoke? So here on the bottom, I'm going to show you smoke-specific PM2.5. So PM2.5 are the really fine air particles that can penetrate really deep into the lungs. And we know that this stuff is really bad for you. It's what gets regulated broadly. It's what a lot of our health guidelines are about. And for reference here, our annual guidelines are somewhere in this range around the world. But during wildfire smoke events, we can see things really, really far beyond 40 micrograms per cubic meter. Okay, so up here, here's our distribution of the wildfire smoke days we see in California. And so what you'll notice is that a lot of the days are really in this low area. So most wildfire smoke days are not the really extreme things that we see on the news, but they're these moderate days because wildfire smoke blows far away. And so we end up with sort of this dissipated smoke that isn't always this thick cloud that we see again in the news. But there are some of those really extreme days. Okay, so on the y-axis, I'm going to show results from a study in which we looked at changes in emergency department visit rates per 100,000. You'll notice where the zero line is. And so at low to these moderate levels, from around 0 to 10 or 15, we do see increases in daily ED visit rates. And so again, what we're saying here is at low to moderate levels of wildfire-specific pollution, we see causally higher ED visit rates, but at really high smoke levels, we do recover this decline in ED visits. And so we sought to really try to understand what's going on here. And one of the big sort of explanations that we might have is that people change their behaviors. They know it is smoky. These really extreme days, they're all over the news. People know it, they can see it, they can smell it. And so maybe they're changing their behaviors. So people might stay indoors, which could be good because maybe it's less polluted indoors than it is outdoors, but it's also probably quite polluted indoors. But in particular, they're reducing other activities. So going outside is risky. You can get into a car accident, you can roll your ankle while hiking, you can get bit by a snake, any number of things could happen that could lead you to go to the ER. So to investigate this a little bit further, we separated all of the causes into individual specific reasons for going to the ED, and we get something that looks like this. It's going to be a complicated picture, but I'll pull out some key points. The first key point is that respiratory visits are going up no matter what, but that all of these other visits are going down at these really high levels. And so again, what we're seeing is a function of both human behavioral changes and also reasons people are going to the ED. So we see fewer accidental injuries overall, and maybe there are some non-urgent visits that are getting delayed beyond a week because we're accounting for a whole week worth of visits. And the same is true even if we look out a little bit further, 3-4 weeks. We still see, again, respiratory conditions are going through the roof. A day with moderate or extreme wildfire smoke is increasing asthma-related ED visits by 50% or even 200%. We see largest impacts in zip codes with the highest fraction uninsured. Again, we're in California. Uninsured populations may be using the ED as their primary care, which I don't think is good for welfare. And then finally, these aggregate welfare impacts, we don't really know what the answer is. I like to go hiking, even if it means I might break my ankle. And so if I'm staying inside, that's not necessarily a good thing, even if I might look healthier on paper.
So can I interrupt just for a minute?
Please.
Yeah. So are you saying then that really the real killers are the days when people on the non-smoky days are the real killers? Actually, that's what you're saying, isn't it?
Well, it's an interesting point. So killers is an interesting term that you're using. We're talking about healthcare utilization here, which is very different from mortality. On average, there are something like 40 times the number of ED visits than there are deaths in California. And we'll talk a little bit more about how important that difference is for understanding health impacts a little bit later on when we talk about temperature. So for death, it's not clear that the same relationship holds. The other big point I would say is that this is in California, where maybe people are better suited or better adapted to knowing when it's smoky. So maybe when it's really smoky out, people in California in particular know it's smoky out and maybe are less likely to take action. I think we don't know what the answer is to your question, Matthew. It's very good, though.
And we know that the risks are, we know about the risk from inhaling smoke. It hurts lungs short term, but what do we know, or what are scientists finding out about how repeated exposure might people's effect in the longer term?
Yeah, again, it's a really, really good question, and it's actually a little bit trickier to understand than we might want it to be. We know that generally air pollution is very bad for you. Again, PM 2.5, it's bad for you. It's bad for you in the short term, and it's bad for you in the long term. But the specific long-term health effects of wildfire smoke in particular, we have not a great understanding of them. And that's for two major reasons. The first is that we haven't been measuring wildfire-specific smoke for a long time. It's very difficult to identify when it's smoky, where it's smoky at a wide scale. And so we're only just now getting good at that through a combination of satellites, big data. And so in the US, we've got daily wildfire smoke estimates only since 2006. So in terms of generating long-term impacts, we've only got this runway of about pushing towards 20 years now. So only now, I think, are we getting stronger studies on long-term impacts. The second big question is that wildfire smoke has a different exposure regime, for lack of a better word, as compared to wildfires, as compared to other sources of pollution, insofar that wildfire smoke is episodic. It comes in these big waves. There can be very high levels. There can also be low levels, but it's not very constant. And so each day, the average American maybe experiences 5 wildfire smoke days a year. All the other sources of PM 2.5 we're experiencing all the time at a sort of low level. And so it's possible that that there are different long-term consequences, but in general, it means that it's hard to study the long-term consequences. We're much better suited at understanding the short-term impacts of wildfire smoke. And so coming into the future, this is an important uncertainty, and we really need to keep up our monitoring and continuing to do studies. But I do know that there's a lot of work ongoing trying to understand long-term health impacts.
I saw one study that I sent to you that suggests that wildfire smoke might be 10 times more harmful than city air pollution. But it's interesting that you're saying we don't have long enough data to really prove this to be true. I'm interested in why it's so toxic.
Yeah, so we think about wildfire smoke in a few different ways. It's not just bad air like we see here. It's all this sort of complicated mess of stuff. So there are fires that burn forests, and these release a mixture of fine particles, gases, and again, they blow far. They bring up a lot of things, organic carbons, and also some metals that are in the soil. So there are all of these things that are getting aerosolized, and we know that they're bad for the lungs. So we have fires again, burning forests, but recently, and drawing on these sort of disturbing images from LA, we know that fires in this wildland-urban interface burn all sorts of other things. And these, when we're burning homes, cars, batteries, bicycles, what have you, these are really, really toxic swirls of messes that people are breathing in. And if we're not protecting ourselves, these are the sorts of things that can be particularly toxic. And so again, we're only just now getting better at understanding how and what exactly is in these fires and what's sort of staying around in the long term. So this is one of the big reasons that wildfire smoke might be more toxic. I think in general, again, I don't think we have an answer that wildfire smoke is 10 times more toxic. There's one study that showed observationally, but that study really wasn't designed, as far as I can tell, to identify whether wildfire smoke was more or less toxic. It was really about identifying the impacts of wildfire smoke, and then they compare it to impacts that they see from other sources. So again, is it that wildfire smoke exactly is more toxic itself in a sort of single unit, or that typically we get exposed to a big dose of air pollution all at once when it's wildfires? That, I think, not so certain. These wildland-urban interface fires that are blowing smoke across cities, I think that these are really bad for you.
So I wonder, I imagine that air quality warnings are already incredibly strict during fires. Do you think based on the toxicity, they should be even stricter?
It's a good question. At the end of the day, the way in which public health is set up in the U.S. and in a lot of places is that our objective or the sort of modus operandi is telling people to protect themselves. That people get told there's wildfire smoke in the air, and we're not, at least in the U.S., not doing a great job of smartly thinking about how to protect people from wildfire smoke. We're much better at protecting people from, what comes out of cars than if those cars get burned themselves. So we have regulations on tailpipes, we have regulations on factories, we have those things, but wildfires elude the current ways in which we protect human health in the US. And so telling somebody that it's really smoky out, I think is a good move. There are now some forecasts for wildfire smoke, just as there are sort of other kinds of forecasts where we know, preceding the LA fires and recently in San Diego, there were many warnings that there was high risk of wildfires. And so those warnings help. But at the end of the day, I think we do need sort of more concerted effort to think about protecting public health.
Can I ask you something else? Yeah. Edie, sorry, is that right?
Go for it.
Yeah. So do you think that I'm interested that you mentioned the smog and that culture in California. Do you think any of that can play into dealing with wildfire smoke?
Can you say that again? I'm not sure that I quite followed. The culture of smog?
The culture of when I lived in California, you had to get your car smog checked, and was smog was very much part of the public discourse around public health. And do you think any of that will be brought into this narrative about wildfires?
Yeah, it's an interesting thing. I mean, part of again, with the smog tests and stuff, we just did ours. It's something that I can do on my own. But it's very difficult for an individual to protect the state from a wildfire event. We can take collective action. If we own property, we can, protect it. We can we can put in efforts to reduce wildfire risks on our own property, which everybody is supposed to do. But there are also large swaths of national and state forests that are sort of outside of our domain as individuals. And so I think, in my mind, when we're thinking about trying to protect the public's health from wildfire smoke, there are, I guess, three or four different ways of thinking about it. First is preventing fires in the first place. And I think that we need to think through how we're treating forests and how we're thinking about encroachment of our urban landscapes onto forests and risky areas. There's also this sort of long-term climate change question about drying, periodic wet and dry years, the growth of available fuels. The second question is, when a given wildfire does begin, that maybe we should be thinking in our calculus, what are we trying to prevent? There are some good fires, people say, fires that, burn, we have controlled fires and things like that, prescribed fires. Those fires can be useful for forest management rather, but what are the consequences for health? So if it's not near anybody and there isn't wind blowing in a dangerous way, then maybe that can be safe for human health. But if there's a fire that's burning, deep in the wilderness, but the smoke is getting blown into a city, maybe we need to be thinking about that fire a little bit differently. And so there's this thought around maybe there's a way to think about fire management that centers both human and ecological health and doesn't just focus on avoidance of property destruction and things like that. That maybe we think about avoiding fires that really blow a lot of smoke over populations. And beyond that point, we can think about enabling people to take protective action, doctors being aware of the kinds of illnesses that might be associated with wildfire smoke, helping people to get prescriptions before they need them, these sort of prophylactic initiatives that people might take on.
I have a question, probably a solution for that. Probably, do we have any institution that, for example, tests the material when they burn, what kind of emission they produce? So when let's say you buy a car and the car has battery, has things, you already have like a code there. If the car catch fire or burn, you use this. You need to use this Mac or you need to be aware about that. So the regulation can be like building the material to be more resilient, or maybe understanding. Do you think it's any regulation, because as Matthew mentioned, you have a smoke, right? But then you might have it for material like a leather when you burn carry bag, when you burn because you have a house that catch fire, and then the neighbors, for example, based on the regulation, they might have like a certain chemical that you, for example, that do you have any regulation, any labeling of when you buy something that say this is the toxicity? In case of you burn it, you need to take this action to, for example, avoid poison yourself or to mitigate any effect of that. Because in Los Angeles, probably you have a cars, a battery, everything, name it. So that is a question, but could be also solution. But I'm just was. Do you think anything could be done to solve that or to help to mitigate that?
Yeah, it's a very interesting way of thinking about it. I don't think that people are quite thinking about it in that way. I think people mostly think about, trying to treat things with flame retardants so that things don't burn. But the real challenge is that these kinds of wildfires are extremely hot and destructive. And so that what you're seeing here in this image is that everything is burned. There's very little that's standing. And so all of that has gotten thrown up into the air and then fallen back down. And sort of thinking about that long-term phase out, I think is a really good question. In the short term, I'm not so sure how, it would require me to replace the lamp I have on my table, maybe. But I think it's a good way of thinking about it.
Interesting. Should we move on to some of your other work, Carlos, around heat and health?
Sure.
So you did another study in California that looking into what could happen in the future, and in hotter futures, you're predicting that heat-related emergency room visits rise, but deaths actually fall. So talk us through this.
Yeah, thanks. So yeah, again, this is some work about non-optimal temperatures, which is a wordy way of saying, too hot and too cold. But it is sort of useful to walk through a bit of the logic of how we generally study the health impacts from non-optimal temperatures. So what we do a lot of the time, similar to the way in which I talked about the wildfire smoke work, so we have on our x-axis down here temperatures from both cold to hot, and we think about impacts on a population. So we're using counties or zip codes or states or something like that here, and we're thinking about temperatures at either the annual, monthly, weekly, or daily level. And so oftentimes when we're making these relationships, we'll have relative risk here of mortality on the y-axis, and we have some minimum mortality threshold where the risks are as low as possible. And so we usually center, or for comparability, we often center our relationship relative to this. And across a large number of studies now, we see that hot temperatures increase risks of mortality from all causes, but also so do cooler temperatures. And so we get this sort of a J-shaped or U-shaped relationship between temperatures. And that's why we refer to them as non-optimal temperatures, because of this sort of notion that we're centering it around some minimum mortality threshold. So an important thing to then consider here is both the increase in risk from these cold and hot temperatures and the distribution of days. So total impacts from non-optimal temperatures is that combination, right? We can think of it as the, some amount of where the days are, the number of days, and then also the sort of shading of this risk here, and then the shading of the risk under here. Okay, so what we end up finding around the world, almost everywhere, is that here's going to be share of deaths from all causes attributed to cold or heat. And what we see here is that moderately cold days vastly outweigh damages from death as compared to extreme heat. And so while we talk a lot of the time about extreme heat, because it's very acute, and on very hot days, we can say increases of death of 20% even, maybe even higher if it's really hot. When we sum across all the days, it's these moderately cold days that appear to kill. And it's a bit challenging, I think, for people to wrap their heads around how 15 degrees Celsius day might lead to increased death. And so it's a really tricky thing, I think, for us to understand, and we're still actively reconciling with it. So one of the key explanations is that, again, most deaths are due to non-optimal cold temperatures, and these cold days far outweigh hot days. So we're seeing here in Barcelona. And so these extreme heat days, which even though we're seeing increased risk of death of 150%, there are very few days in a time series. Okay, so we take this logic and we apply it to California. So we take a look at non-optimal temperatures in California from 2006 to 2017. We look at first deaths. And so we see here, again, on the x-axis, daily mean temperatures, on the y-axis, change in monthly mortality rate. We see that sort of typical U or J shape here. Very, seems about right. Then we take a look at not just deaths, which we know the most about because we've been recording deaths in systematic ways for a very long time. We also take a look at hospital admissions, which, although they're a little bit jumpy, still generate roughly the same shape. So hospital admissions fall somewhere between, deaths and emergency department visits. They share much the same properties as deaths, the same reasons that people die. They often end up in the admitted to the hospital, generally concentrated among older adults as well. But ED visits show a completely different relationship. We find this sort of linear relationship here, where cooler temperatures, we see fewer ED visits, and warmer temperatures, we see more ED visits. Okay, so given this, we try to understand why. One is younger people make up most ED visits, older adults make up most deaths, and they have different illnesses. So perhaps they respond to non-optimal temperatures differently. We also know that, again, different causes, the reasons people die are very different from the reasons that people go to the ED. As I mentioned before, ED visits, that's a lot of injuries, symptoms, things like that, whereas people die a lot from cancer and heart disease. The third and final point that I alluded to a little bit earlier, Matthew, is that health does not equal healthcare utilization. People may be sick but don't use the ED, and people that use the ED maybe aren't that sick. But it's a really important insight into these sort of kinds of events that might be contributing to overall ill health across the world. Okay, so now getting to your question, Edie, in the future in California, we'll see fewer cold days, more moderately warm days, and more hot days. So what we have here are distributions of daily temperatures. Mostly what you're seeing here is as we're going from the gray to the red, we're seeing fewer cold days and more hot days. There. And that means that into the future, for ED visits, because we see this linear relationship, we're going to see more ED visits from hot days, more ED visits from cold days. But when we look at mortality, because of that U-shaped relationship in the distribution of days, we're actually going to see fewer deaths, we think, from temperature, some more deaths from heat, but fewer deaths from cold, and fewer deaths from cold that outweigh the increased deaths from heat. So this is a set of projections that we do out to 2100 based on future distribution of days. This is similar to what we've seen in a lot of other temperate climates. A lot of Europe, we see ambiguous impacts, again, due to generally fewer cold-related deaths and more heat-related deaths that way out, but there are definitely some parts of the world that are going to be hit a lot harder. And I think there's a big question around adaptation. What's going to happen in the future? How are we going to be changing?
Just a quick question. I'm wondering, how does humidity play a role in this? Because obviously when it's humid, it feels a lot harder and it can be more difficult for the body to cool down.
It's a really good question, and it's a big topic of debate. I think in general, the biology does suggest, and certainly my lived experience is that when it's humid out, things feel much worse. My body can tolerate it worse. The epidemiology, I think we're sort of not sure. I think a lot of the time when we account for humidity, we see basically the same responses. So if we're thinking about climate change, if there are big changes in humidity under future warming, then maybe we'll have to think about heat differently. I think, but hot days that are really humid are probably a little bit worse than hot days that aren't so humid for the most part, right? But maybe if it's humid, you know that it's really hot and humid and you feel gross, so you stay inside. And so maybe you end up with less exposure. So there are these sort of complex dynamics. All of these models account for precipitation in them, and we get a little bit close, but it's a really good point, Romy. Thanks.
Can I ask a question?
Go ahead.
Yeah, can I ask a question? You mentioned before that the rate of mortality due to temperate cold or relatively colder days was much higher than everything else. I didn't quite get why was that. Why? What? Moderate cold. That's the word.
Very good question, Diego. So the key point here is that it's not the rate of mortality that's higher, but it's the prevalence of deaths. So the share of deaths from temperature, most of them are from moderate cold. That's what we're seeing here.
But is that you are attributing the death to the temperature, or it just happens that during the those type of days there was more death, whether it was a car accident or whether it was cancer?
Yes. So a lot of the time we think that sort of in our environmental epidemiology, that's the same thing. So it's tricky, right? Because it's not necessarily that this person got it's not that this person got hypothermia and died, but it's that statistically, what we're seeing is that there are increased rates of death on days where these temperatures are where they are. And we've done everything we can to eliminate all of the other reasons. And so what we're seeing is that there's something about days where it's, in these moderate temperatures that is causing increased risk of death from all causes.
But we don't know why.
And we don't exactly know why, but we try to break it down, right? So we try to break it down whether it's the same day. For cold, it's mostly these lagged effects that we see. Heat, usually the worst days are the same day or the next day. We see most of the deaths accrued really quickly. Cold, the deaths seem to come a little bit later. And so again, there are these sort of somewhat hard to understand lagged effects. The big point here is that most days are in this bucket here.
Yeah, very interesting the point, because it's very interesting. I have one quick question. Have you considered the infrastructure? Because countries that are cold tend to suffer more when they have a heat wave. Countries that are normally hot, like for example South America, California, they say is very hot in the bay, in the valley. So a hot day will be natural. So people will take care of themselves a little bit more, and the infrastructure will have like a more fresh. But if you put the cold in England, for example, 45-degree here in Bristol, it will kill people like ants. Many people, because you cannot, the
Right.
house
So
are not
how
prepared.
culturally and specific and geographically specific is the data, Carlos?
Exactly, the geographic.
Yeah. So in general, your intuition is completely right that geography matters a lot. And what we often think is that it matters what you're used to. And so part of that is sort of cultural adaptation. Again, this idea that when you know it's really hot out, you know it's really humid out, maybe you stay inside more. You know not to go hiking in Death Valley when it's really hot. But if you are used to very cool temperatures, then even a moderately hot day might be an issue. And so we do see that the shape of the response function differs depending on the location. So I think there are 2 points to make. One is all of our data allow these responses to be pooled across different geographies. And so the way that we do it is we are comparing, San Diego County to itself. And comparing Sonoma County to itself, places with different baseline temperatures, and the same is true everywhere. So again, that's point one. So statistically, we try to take care of these things. But the other point is that, yes, definitely, our intuition is that places where it's typically cooler suffer more when it's hot out, and places where it's typically hotter suffer more when it's cool out. And so part of our question about adaptation is, well, maybe we'll get used to it. But we're not really seeing that in the data. And I think that's one sort of useful point to make here. Yes, Andrea.
Yeah, Carlos, thank you. Really interesting data. So Kirsten and I are here scratching our heads, trying to sort of intuitively follow. One question, hotter days happen in the summer in the Northern Hemisphere, colder days happen in the winter. If you plot that data on let's say a year, like all January, February, March, does your intuition remain the same?
Yeah, it's interesting. So yes, we find these relatively consistent patterns, but one really interesting point is that we also know that people get sick from different things depending on the time of year. So in the US, we have 4th of July, we all go out on in the Midwest, we go out on a boat and people drink and they party, and then people end up in the hospital from poisonings. In the winter, we're all together inside and everybody gets sick from the cold. And so these things have different patterns. And so there's this interesting thing that happens when, temperature impacts depend on the type of thing that's the issue. And so, we see this kind of funky distribution. So there's some studies of extreme heat that just look at impacts of extreme heat in the summer, and other studies that look at just impacts of cold during the winter. I think that it's useful to look at the data for all periods of time. But again, just as we compared, San Diego County to itself, we're also comparing January to itself. So what we're trying to find is an anomaly, basically a particularly hot, Wednesday in the 3rd week of April is what we're comparing against in these models. And so we're doing this really, really careful comparison that happens. So, it's a really good point. And that's sort of what makes this so hard to understand and sort of conceptualize, to create this full narrative about how it is that temperature or smoke or any hazard is impacting us, because we keep changing. You know, we as humans have our own seasonal patterns, just like the weather does.
I'm interested in this, but I also know we have two more topics to get through. Carlos, I want to talk about your work in Ecuador. Do you have any more points to make on heat and health before we?
Yeah, two more points. Well, so I already went over these things, but the other point is this question about, are we adapting to climate change?
Yeah.
And I just wanted to show these. So this is US mortality. Again, we've centered it around a minimum mortality temperature. And here's for a bunch of the EU countries. And in the blue is the 1970s, in the red is the 2010s. The same is basically true for the EU. What we're seeing is these functions look really similar. And that's the takeaway here. These are about the same. And so we're seeing, you know, a month where the temperature is about 35 degrees Celsius in the US. We see about a 0.8% increase in monthly mortality rate, a little bit smaller in the EU, a little bit more temperate climate. But again, the point here is that these are pretty similar. The one exception is after the 2003 heat wave in France, the mortality response is very different. France appears to have flattened their mortality rate from extreme temperature a little bit.
Interesting. Let's move on to some of your work in Ecuador. Tell us what you were researching and what you found there.
Yeah. So this is really where I got started in environmental health, is looking at folks who use firewood for cooking in these sort of traditional stoves. So these are stoves that I've seen all over the world, India, Honduras, Ecuador, Ghana. And what we see is that there's a really large burden of disease from this kind of polluting fuel use. There are about 2.5 billion people around the world that still use traditional fuels like firewood, charcoal, dung for their daily cooking and heating needs. This results in somewhere around 2 million premature deaths each year from the air pollution consequences. So it's about 7 to 10% of all deaths in low and middle income countries. It also accounts for about 2% of all greenhouse gas emissions. And if we total up the damages for mortality and CO2, it's about $1.6 trillion each year in damages just from these cooking practices from these folks. So for a long time, we've been thinking about what are the solutions. And so the best emerging solutions these days are clean burning fuels, gas, ethanol, and electricity. And so what we're trying to do is figure out how we can get there and what the sort of consequences are when we do get there. We've seen in general, global premature deaths from household air pollution are falling a bit, but progress is fairly slow because in particular in Africa, we're seeing very large proportions of people still using firewood as their primary cooking fuel. And we're seeing population growth in Africa. So the total number of people still using polluting fuels has been about the same for a while, even though there have been declines in overall proportions. The real challenge then is finding places that sort of buck this trend and have made big changes in relatively short periods of time. So that's where this case study in Ecuador has emerged, because Ecuador has made liquefied petroleum gas, kind of like your backyard propane cylinder, very cheap for the last 40-ish years, pushing towards 50 years now. And so Ecuador's curve looks very different from the rest of these, where Ecuador has been able to replace the use of firewood with gas in almost all households in the country. And so what we've done for our research in Ecuador has really point out how this heavily subsidized gas has helped everyone to replace burning wood with gas, leading to cleaner indoor air. We've also seen that there are reduced deaths from children under 5 from lower respiratory infections like pneumonia. We've also now started to look at work in Ecuador where they're now trying to switch out the gas stoves with induction stoves. So we've been looking at work that tries to understand impacts on air quality, health, and climate change, and that these transitions do appear to be have high potential for success.
I'm really interested in, I knew the implications of using wood, but I was surprised actually about the health and climate implications of so many people cooking with gas. I'd love to hear a little bit about that, and then I'd love to hear how Ecuador succeeded when other countries that tried doing the same thing failed.
Yeah, so on the first point, about 7% of all greenhouse gas emissions are from residential sources. And so a big portion of sort of everybody's effort to reach net carbon zero goes through residential electrification in some form or another. And so that is a real big sort of point, trying to get from gas to electricity powered by renewables. The logic there is pretty simple. Electrify everything and have that electricity come from renewable sources. But it will require a lot of investment in the electricity grid to make sure that we always have reliable electricity. If we have a power outage and we rely on electricity for everything, what are we going to do? And so there's this big challenge here, and there are lessons to be learned on, the multiple use of fuels, which we call fuel stacking. So where you have a bunch of electric sources, but also you have some gas sources or some firewood sources, and trying to understand both the consequences of that and the logic of it. I don't remember, you had another question.
And then about the induction stove program has cut hospitalizations. You mentioned the impacts on health, and I'm wondering why Ecuador succeeded in moving people from gas to induction to electric when other countries' efforts have failed.
Well, I think that there haven't been that many other efforts on a large scale like Ecuador. So Ecuador set out this goal to try to get 80% of all households using induction. So Ecuador has a huge amount of hydroelectric capacity, and for periods of time was exporting electricity to other countries because they had such an amount of energy. Unfortunately, droughts, make that a vulnerable commodity. And so there are challenges there. And so what Ecuador did is they tried to offer an equivalent amount of subsidy as to their gas subsidy for electricity, and then provide incentives for people to buy the stoves. And it's resulted in about 700,000 households making that switch, which I think is one of the biggest transitions in a short period of time. Definitely one of the biggest transitions in middle-income countries. So it's a combination of a real effort by the government to make these switches, some smart incentives, and they invested a huge amount of money in upgrading their electricity grid to support it, even in sort of rural or peri-urban parts of the country. So there are some pushes now. Nepal, I know, is pushing, and then of course some cities as well in Western and industrialized countries.
Well, maybe that's a good point to switch to the final topic, which is this whole gas to electric transition. You just talked about the grids. And I wonder how many US states have clean enough electricity to switch from gas to electric swaps easily.
Right. Yeah. So the trade-off here is an important one to think about. As a consumer, if we're concerned about the climate impacts of our gas stove, I offer a couple of thoughts. So one is we can think about combustion, and so skip through a couple slides here. So here's our sort of US grid readiness map where lighter colors are cleaner. And then I'll translate this to thinking about where we need to be. So here the darker colors refer to states that are sort of already there, already clean enough, and the very lighter colors are not quite there yet. So from the point of emissions, we have to think about, when we make that switch from gas to electricity, gas burns fossil fuels, that electricity has to be coming from somewhere. And so our electricity has to be clean. So we do see some portion, of US states that are already pretty clean. Parts of the Northeast, parts of the South in California and Idaho appear to be pretty clean. A lot of parts of Europe are there. Some parts of other countries are there too. So the complementary question then is, should we be making the switch? If you've got a really good gas stove, and you're concerned about climate change, I would think about the fact that your gas stove has embodied emissions in it because it was produced The same is true for an induction stove. It has embodied emissions, the sort of life cycle of emissions. So I think there's another incentive, which is, making the switch for health, which might be compelling on the short term. I think as a society, we will be making the shift towards, electricity powered by renewables in general.
Do you think states like California should prioritize appliance changes? We're just talking about the switch from gas to electric stoves before grid upgrades, or is it the other way around?
Yeah, I don't know exactly about like the ordering of things. And I think, in general, we're going to have to make both, we're going to have to move both of them forward. The challenge there is that, appliance upgrades are often individual consumer efforts, and grid upgrades are state and utility efforts. And so we'll have to be pairing both. Absolutely to be moving forward. And again, there are incentives in the US through the Inflation Reduction Act to provide rebates for purchase of certain electric appliances. And so I think that there's a strong effort. But at the same time, we do have a sort of real a grid readiness challenges around, not having power outages, ensuring that our, electrical grids don't cause wildfires, and ensuring that they're resilient and robust.
We've got 10 minutes left, so I want to make sure people, if you've got questions, just unmute your mic, raise your hand, give a wave. I was just home in Berkeley, and they tried to put a ban on natural gas in new buildings, but then a whole bunch of restaurants said, we don't want this, and they reversed the ban as a result. In fact, a restaurant group brought a lawsuit. So I wonder if there's anything to learn from the cautionary tale.
Yeah, I think the thing to learn is that we ended up getting this politicized somehow, and people have strong opinions about how they cook. And part of that, I think, is a long effort from fossil fuel lobbying starting many decades ago that convinced people that gas is the right way to go. And certain people really live by it. My mother-in-law, they just thought about which stove to get, and I lobbied a little bit for induction, and she refused very hardly, very, very firmly. And so this, question in Berkeley, did become a sort of legal question, and I think does push us more towards incentivizing cleaner options than eliminating the sort of polluting option. And I think that's generally the way to go, around the world, that we should create the facilitating circumstances for people to make decisions that are healthy for them and for all of us. But yeah, it's a real tricky one, I think, thinking about how we're going to get there.
Can I ask a question about Ecuador and India?
Sure.
So I think for a country that's as big and sort of as rural as India, where people might not have the wide choice to pick what they use to cook their food, I'm wondering what we can sort of learn from Ecuador and sort of transfer that to potentially lower income areas. And so places like Mumbai, where I think they've subsidized LPG gas for a number of years now. But sort of outside of big cities, what could they sort of work on to sort of, I guess, educate people, but also increase the sort of availability of different sources?
Yeah, it's a very good question. And the biggest changes that are happening in the world with respect to energy transitions that are happening in India. And so starting in 2015, India began a program to provide gas stoves to poor women, below poverty line women. And so in the past, sort of in the first 4 or 5 years of that program, they reached 95 million households got a gas stove for the first time. That's just a radical transformation. The challenge, as you've alluded to here, is that people are too poor to afford a cylinder at the full price. And so the lesson here, I think, are twofold. One is what we see in Ecuador, is that a long time of making gas very cheap and affordable has resulted in wide distribution networks. So there are very key sort of tenets of getting clean fuels to be used nearly exclusively. One is they have to be affordable. In Ecuador, we get a check mark here. In India, we get a big X, because gas cylinders are simply not affordable for the majority of poor households who just got them. In Ecuador, consistently and easily available, you have to always be able to use the fuel that you want to use it. Otherwise, you'll use something else. So a lot of people, if they're not certain they can get gas because it comes in cylinders and isn't piped into our home, they'll keep the firewood option. So you see the same thing in India, where if there's uncertainty about whether you're going to get your fuel, then you're gonna hold on to something that you know you have, which is going to be firewood. So in Ecuador, we mostly get a check mark, but in some places there's a bit of a question mark. In India, again, in some places we get a sort of half dotted check mark maybe, but for the most part there's a big X. And then gas, really, people are able to meet almost all of their needs with it. But there are some synergies here between, affordability, availability, and ability to meet all needs via rationing. So basically, some people will cook really big meals for a lot of people. And if you're a little bit uncertain whether you can go through your whole cylinder and get a new one, then you're going to be using your firewood for that. And so here's a big question mark. The other thing is that gas stoves are super different from an indoor fire. That, gas stoves don't offer the same sort of heating co-benefits. So for parts of the world that are very cold and people rely on their stoves for that, then there is a challenge there. But India has made massive transformations, and I think the real key to making sure that those benefits stick is going to be making the fuel affordable. It's going to have to be very cheap. And India has played around with a few different options that I think are good, but they need to keep at it.
What lessons for richer countries like the UK?
I think that it's going to be much the same, that fuels need to be affordable. The switch needs to be affordable, and we have to be sure that people can, always use electricity. So if there are consistent power outages, then, I would be concerned a little bit as a household about relying exclusively on electricity. And I really do think that people can cook just fine with induction. So the sort of thing that I focus on here is, let me see if I can just get a simple here. The thing that I focus on is risk reduction. And so if I'm concerned about health, which I am as an environmental health scientist, and I know that burning gas increases pollution indoors, then I'm going to try to not burn gas. And so on my stove, we have a gas stove, but I use induction burners as much as I can. When I'm heating up water, I use a hot water kettle. When we're making rice, we use a rice cooker. And these are efficient and clean ways. And we only, when we do use a gas stove, we're trying to run air purifiers, we're opening the windows, we're using the fume hood and things like that. That's my big advice to people, is trying to think about how to minimize risk where you can.
And I was interested, yeah, go ahead, Andrea.
No, Carlos, I think that makes a lot of sense. I'm thinking about California, where the trend is to increase the electric demand to the house, right? You got air conditioning, you go out and buy an electric car, you need to charge it. And, I have to think that the stove, in the great scheme of things, is not a big delta load on the usage of a house in terms of amps. I like your approach of going for the health component, though. I think that is something that can resonate much more, because, Kirsten and I just switched to convection very recently, and
Induction.
I'm sure to induction, and it is a mindset you have to change. So
Plus a pan thing. You got to get new pans, right?
you get new pans, and then you don't know the temperature. So, but you know what? It's fine. You learn how to use it. But the other thing that it's a little bit of a headwind is that natural gas has always been looked at as the clean alternative. Even their slogans, clean natural gas. So it's kind of hard to understand, how that could not be, okay to use.
Absolutely. It's such a challenge. And I think, there are several components of the challenge, but at the end of the day, health is something that we can generally all agree on is important. And we also know that a big portion of health is behavior change. It's about messaging, it's about telling people and empowering them to make decisions. I think that telling people the certain way to live is not always the best way to go, but really, my sort of mindset is trying to help people, try to provide the facilitating circumstances for people to make healthier choices. And a lot of the time, what I found, especially with the work in low and middle income countries, but even here in California, is that a lot of the time, the healthy choice isn't even a choice that somebody has. I'm fortunate enough to be able to buy an air purifier. We have a few of them, and that's a healthy choice that I know I have because of the privileges I have with the job that I do, and that I can afford it. And so, trying to think sort of about these sort of ideas around risk mitigation and how we can help people has really been a focus of the work that I do.
Thank you very much, Carlos. Well, that's our time. I can't believe it's been an hour. Pleased that I got through at least half of my questions. We covered a lot. We covered wildfire smoke and health, heat and health, clean cooking solutions, the gas to electric transitions, and a really interesting focus around cities as well, and not just in the United States, but also around the world. So, Carlos, thank you so much for being with us.